question 1 here, we're just asked to write the null and alternative hypothesis for the following. Is a coin fair? So we could say that H0 is equal to, if the coin is fair, 0.5. So therefore H1, well, this is a bit silly because H1 would also be equal to 0.5 if H0 is equal to 0.5. But we're going to say here it's not equal to 0.5. Well, you can see here that H1 could be equal to 0.5. So, you know, not a question that's going to come up by anyone who spends a bit of time creating an exam. Only 20% of people who quit smoking succeed. So my H0, if we're going to test this theory, H0 is going to be equal to 0.2. So H1 is not going to be equal to 0.2. In the 70s, only 30% of young people who graduated from second level went on to third level. Isn't that quite shocking? So H0 is going to be equal to 0.3 here. And H1 is not equal to 0.3. And you can keep it this simple in an exam. You don't have to write loads of words like I did in the last video. So the editor now questioned. The editor of a weekly magazine is concerned about typographical errors and believes that about 1.5% of the number of lines printed will have one error. An examination of 650 randomly selected lines revealed 11 lines that had one error. Does the sample support the editor's belief and use a 5% level of significance? So his belief, H0, the null hypothesis, is equal to 0.015 for 0.15%. So we're going to say the alternative hypothesis is not equal to 0.015. So let's test this. We have 650. So we have our sample of 650 and then we have our proportion of 11. So think about P, 11 over 650 is going to be equal to P in this case. So we're going to use population proportion. And 11 over 650, does that work out? Don't think so. Doesn't work out too evenly, so I'll just do 1 minus P as a fraction as well. So 1 minus P is not 11 over 650, it's 650 minus 11, which is 639 over 650. So we can create our margin of error here. It's going to be 1.96 by the square root of P, 11 over 650 times 1 minus P, 639 over 650 divided by N, and all inside the square root. And N is our sample of 650. So typing this into a calculator, I'm going to get a value of 0.00991 0.0959154. That's what your calculator should give you, 154. So we don't need too many of these. We'll take up to, we round off the 1 to a 2. 0.00992. Let's take 3 significant figures here. So we have our P in the middle. So we need to add on to P and take away from P our value here. So I'll write P as a decimal, 11 over 650. 0.0169. 0169. I have to add on 0.0992 to get 28620, 0.02682, 0.0169 minus 0.00992 is giving me an answer. I'm going to write it on the left down here. Let's get rid of that 650. Just make it smaller. So on the left down here, I'm getting 0.00698, and all the way up to 2682, 0.02682. So this is my interval. Now, is my original inside this interval 0.015. So if we look at that as the third, second and third gives me 15, 6, 26. So this is between 0, 6 and 26. You can see 15 is actually somewhere in the middle here. So as is within interval, you could say within 95% confidence interval, we conclude that no change to H1. If you have time, write it out. No change to H0, and we can say that whatever H0 was, there are 1.5% of lines printed that would have one error. May as well rewrite this line too.